Good evening, everyone. My name's Mike, KD2UWR. A little new into the hobby. I got into it during the pandemic, but no regrets. It's been super fun, learning a lot, meeting people all over the world, lots of new friends. So I love the ham radio hobby. Is sound all right? More gain? Okay. Okay, how's this? Better? Okay. Where was I? All right. So yeah, just kind of new in the hobby, really having a lot of fun with it. I'm going to present today on AI. AI is not my job. I don't do it at work, but I do use AI every day. And really early this year in January, I got really fascinated with it and just spent a lot of time playing with it, studying it. And I did a presentation for the IEEE a couple months ago. And George noticed it and said, hey, maybe the team here would like to see it as well. So I made a shortened version of it, ask questions, and let's get into it. You can go to next slide. This was a 2-hour presentation I did for IEEE, so I did shrink it down a lot. I'm hoping like 45 minutes, maybe with some questions. So some sections I'll go a little quick, but if you feel like it's quick and you want to pause me, just let me know. But really 3 sections. One, a little bit about like how the AI works, kind of peeking into the mystery of it all. The second one is the prompt engineering, which I find really useful. I actually use this kind of every day now for everyday tasks. I use it for work, and I'll show some techniques that I learned. And then the third one was really just like kind of more of definitions of things that are going on. It's changing every week, and new things are coming out. So I captured a few things that you might find interesting. So let's go ahead. All right. So when people talk about AI, I like to think of it as kind of like 4 different circles. So AI is like encompassing everything. And then a subset of that is what they call machine learning. And I'll describe a little bit what that is. And then a smaller subset of that is what they call deep learning. I'll describe a little more of that in a couple slides. And then something more new, which came around 2017, which is generative AI. So I'll just walk through these 4. So that first kind of smaller subset, machine learning, and there's really 2 types to think about. One they call supervised learning and unsupervised learning. And really the big difference is supervised learning, you need massive, like millions of labeled images or objects or things like that. And around like 2017, they used to say like data was the new currency, that, like labeled data, collecting all this data. And, that's in use today for things like image classification. So maybe a camera is monitoring something and it can classify this as a person or this is a chair or a table. And then there's something called unsupervised learning. This is where the data is not labeled. And a good example of this is recommendation systems. So like Netflix, if you're on Netflix and it says, this movie is, you might like this movie, that's a recommendation system. So that's basically learning based on what you watch, and they call that unsupervised learning. So just some definitions there. Let me go to the next slide. So now I want to get to the neural network, and they call that deep learning. And this is just, I made a rough diagram of a brain. But basically, I don't know anything about the medical industry or anything like that. But my understanding of the way the brain works is, just click through one more time. Yeah. Is you have all these things called neurons, and they're all connected in your brain. And say you were learning to, hit a baseball or something like that, and your brain is controlling all your muscles, and you have your eyes and ears for balance, and all your senses feeding into your brain. And if you actually hit the ball, the path it took from your input sensors to your output muscles is this kind of rough diagram here. And what happens is, like, those paths over time, as you practice, the path gets stronger and stronger. So that you increase it. Just click one more time. And if you miss the ball, the path that it took in your brain from your eyes and your ears as sensors on the left-hand side to your muscles, those paths, those neurological paths would get a little weaker. And you do that, practice hundreds of times and you get better at it. So next slide. So basically, that's what they did. And that's kind of the mystery of this. What they did with the computer is they said, let's just model the same thing. We can have inputs, we can have outputs. It's a whole bunch of ones and zeros. And I'll step through a few examples of this. So I'm not going to go over any math, but I left this in there. This was from the more lengthy 2-hour discussion, but there's no like mystery behind it. It is just basic math of these inputs that get all basically summed up and a weight's applied. And there's a they call a nonlinear activation function, which is like a comparator for those that know electrical circuits. And then, you know, some output. So go to next slide. And the math gets more and more intense when you have thousands of these and millions of these networks. And that's why GPUs and like the price of NVIDIA is skyrocketing, because everybody wants GPUs to do all this computation. Next slide. So what I thought would be useful is like walking you through how it does that same analogy I did with the brain. And there's something called the MINT data set, and it's like a very basic data set. It's 60,000 images of handwritten numbers 0 through 9. And they're not very big. They're 28 by 28 pixel size, which gives you 784 pixels. And it could be a number from 0 to 255, which is basically like an 8-bit number. So I'll walk you through like how this would be done in a neural network. Then go next slide. So I made kind of a rough drawing. So on the left, you have all the inputs of that little handwritten digit, which is, you know, all the pixels, each row, 784 of them. So just imagine that on the left, you have 784 blue circles. And on the right, you have 10 green circles, 1 through 9, and including 0. And then in the middle, you have these hidden layers where things can get summed, and they're kind of like the neurons in your brain. Click through. So the way it works in the computer is it is all numbers. So say you start out, the computer doesn't know anything yet. It has all these weights, and they can be a number from 0 to 1. They're all set at, say, 0.5. Just click through. And what you do is you give it a training number. So you can see over here, I have like a training image, the digit 5. And while I'm training, I give it the sample image and I tell it this is a digit 5. So it runs it through this network that doesn't know anything. Yeah, go ahead. What? So you don't like the top you're right, it's only feeding 4, each one is only feeding like that was just me. Everyone's feeding everyone. I just got lazy drawing the lines. Like I just did something kind of quick and simple, you know? But yes, imagine everyone is interconnected with every other one, and every connection has a weight, which is kind of similar to the brain, where over time it can grow stronger or it could grow weaker. Yeah, go ahead. But good question, Noah. So in this example, like you're training it, right? So I'll say I'm training it with the handwritten digit number 5, and I know it's a 5. So I run it through, and you know its path. It's giving probabilities on the right. It's saying, hey, 42% probability that it's a 2. And that's the highest one. And all the other ones, I didn't draw it. I didn't write it next to it, but might be like 10%, 3%, 3%. So basically the computer got it wrong. So you tell the computer, you got it wrong. So what does it do is it just makes the weight of the path that took to the highest wrong probability a little weaker. So it made all those 0.5s now all 0.4s. And then you do this like thousands or hundreds of thousands or even millions of times, right? And cycle through another example. So here's an example where it got it right. So this path, you know, went through a different way. And you can see here, the number 5, it said with an 80% chance, because all this machine learning is really probabilities, that it's 82% chance that it's the right answer. And we put a 5 in, so we know it's right. So the path that it took that led to that will just increase those. So if you cycle one more, so you just make those 0.5s is 0.6. And you do this literally millions of times. And eventually you get to a point where it's like 99.99% sure that this handwritten digit, it knows is a 5. And that's really the basics of like the neural network and how it works. And it really, like what fascinated me is that they just copied kind of, they were inspired by how the brain works and just said, let's just do that in a computer. So then, so that's neural networks. That's the smaller bubble. And there's one smaller one, which is really what made ChatGPT and all that take off, which is called the generative AI or the transformer architecture. And I don't really know how this works, but the key thing about it is what they call attention. So this little simple thing here, I think will explain what I mean by attention. So if you look at the sentence, she poured water from the pitcher to the cup until it was full. So the it at the end, we know as humans that it's referring to the cup. But if you just change the last from full to empty and keep everything else the same sentence, she poured water from the pitcher to the cup until it was empty, we know that it is now referring to the pitcher, not the cup. But the problem with the network I showed before is it's almost got like no memory as things come in sequentially. So the neural network's great at like recognizing an image or something like that. But if you have like ChatGPT, a whole paragraph or many paragraphs, it's going to forget the things earlier in the paragraph and remember the things later. So what made ChatGPT and generative AI possible is this thing called attention, where in the beginning, they weight all your inputs. So when you put a prompt in there, maybe it's 100 words, it looks at the words, it ranks the words, and it doesn't put them in sequentially. So it puts them in a different order where it can figure out things like this, where the it is referring to something earlier. And just, I have one more small example to help make it a little more clear. So say you had a sentence, the movie started off slow, but the ending was surprisingly good. And the traditional neural network, like that one I showed before, what would tend to happen is it would miss the part, or kind of almost forget the part of slow, because it doesn't have that history, and it may give you something about like good, is surprisingly good, and it may get fixated on that and think that the movie was good, but you're not really saying the movie. You are saying the movie's good. In the transformer one, it's looking at all the words of your input at once. And I'll get to a little bit more on the prompt engineering, but basically when you use ChatGPT, what you're putting it in is called a prompt, and they call that a context window. And, all this incurs cloud costs. ChatGPT is free, but they have premium versions that pay, and you pay for all those. The longer you put in, the more you're paying. So the real reason, they're giving it to free is eventually they want people to pay and businesses to pay and corporations to pay. So I just wanted to do a little bit about AI, take a little bit of the mystery of it away. This is really the meat of the presentation, the prompt engineering thing, because these are things that you can take and go use right away. And what I found most useful. Any questions? Anything? Yeah. Absolutely. It's changing so fast. Like they just came out, I think last month, ChatGPT released, I think it's called O1, which they're saying now is PhD level. It's like tuned for science and math, where the other one, GPT-4 and GPT-4o, was more like a general purpose one. So these guys are accelerating very fast, and they're all competing because, Google's got the same thing. It's called Google Gemini, and there's others. So they're all trying to outrank each other and, add more and more power to it. What? Hey, who passed the exam? AI? Really? Okay. Well, maybe try with the new one from last month. I'd be interested to know if it could do it or not. Exactly. I mean, if you train it on because the exam is a question pool, so in theory it could ace the exam because it could just learn the questions. But yeah. So, all right, so let's jump into prompt engineering. And to me, this is more fun. It's a bunch of examples of techniques that you can use and you can use with ChatGPT now on your phone or your PC. So I just thought basic, very structured. And that's why I made this presentation. I actually made this presentation for my team at work because I saw a lot of people, we were using, we have our own internal version of ChatGPT that's safe, that we don't leak out trade secrets and stuff like that. And when I was talking to people, they were using it in the very, I'll say, basic way, like I have some examples here, explain photosynthesis, or please summarize this document, or write me an email, or summarize this meeting, which is all great. But like, to me, it was like not scratching the itch of like, can it be taken a little further? And with just a little bit of reading and stuff, I found there's some techniques you can use that can like take to the next level. And I think the first thing, go next slide, is to have some kind of a structure. One more. So I think this actually was written by, originally by Facebook, but Microsoft has one and a bunch of other companies. They all say the same kind of thing. And what they say is when you put a prompt into ChatGPT, you should have these 6 things, you should have a task, have some kind of context, exemplars, which is just a fancy word for examples, set a persona. I'll talk about what that one is a little bit, and have a format and have a tone. Just click one more. And kind of just click through. I didn't realize there's a click through. Just one more. So basically, it got messed up, the formatting. Just go back one. Sorry. They're saying, obviously you have to have a task. You have to tell ChatGPT what you want it to do. Having the context and exemplars are highly recommended. And then the other ones are nice to have, but they really help. So I have like one example I made, and I'll just walk through the entire example. So next slide. So you don't have to read this. I'll break this through, but this is an example of a prompt that hits all those items. So we'll click through one at a time. So you can here, explain the importance of thermal management in electronic device design for engineering blog. That's the task. That's what I want the AI tool to do. One more. The next sentence, I give it some context. I say, in your explanation, I'm talking to the tool like it's a person. Discuss why thermal management is crucial, and give it some information there. Next one. In the next sentence, I give it some examples. So here I'm saying describe techniques used in thermal management, such as heat sinks, cooling systems, and their role in maintaining optimal temperatures. So I'm giving the AI tool examples, and this is all in one prompt. The next one is persona, which is probably my favorite technique to use of all of them. And I'll touch more on persona a little bit later, but I'm telling the tool, you are a knowledgeable electronics engineer with a deep understanding of hardware principles. So that, that lets the AI tool know like a little bit more about what I want. It's before it even goes and finds what I'm looking for or answers what I'm looking for. The next sentence I touch on format is I want the explanation to be concise, paragraph, 150 to 200 words, and one more. And then I can talk about the tone. I wanted a professional tone with, emphasis on clarity and practical relevance. So you don't have to have all these in a prompt. This is probably a more wordy type of prompt, but I do find it useful to have at least some of these elements. Okay, so now I'm going to get into some individual techniques that touch on those things, but that you can use when prompting. So maybe go to the first one here. My favorite one, persona. So when I use all these AI tools, I talk to them like a person. And the best thing to do to talk to them in person is kind of tell them what person they are before you talk to them. So like I have one that's basically my admin at work. It writes a weekly blog for me, for my team. It summarizes things for my boss. All that kind of stuff. And I say, hey, you're an executive admin, you work at Fortune 500 companies, and I need you to do A, B, C, and D. One fun one that I like is I've been trying to learn Spanish for a little over a year now. You can actually use these tools and say, hey, you're a Spanish tutor, and help me practice conversational Spanish. And it'll talk back and forth with you in the tool like it's a real person. Or you can use it, you say, hey, you're an engineer. We use this at work. Maybe I wanted to brainstorm new ideas and things like that. So we'll say right up front and set the persona. So that's what persona is about. It's basically just telling this blank tool what you want it to be in the session that you're using. And if you use ChatGPT or all these tools, a lot of them save the histories. So specifically like the Spanish one, I could start a conversation, turn it off and come back tomorrow, continue my conversation, continue it again. And it's kind of like a free Spanish tutor. Okay, next technique. Am I going too quick? It's good? All right. Next technique is called self-prompting. And why I like this one is, so say you didn't remember anything that I spoke about today and you didn't remember any of the techniques. You could basically ask the tool to ask you to answer those items before it answers you. So instead of thinking of like, what's the format and the tone and all this stuff, you can basically remind the tool up front to ask you and then answer the tool with the questions, and then it'll give you the answer you're looking for. So in this example, I stated up front, I need to build a presentation on using AI in the workplace to improve efficiency and effectiveness. And this is like a key phrase. I wrote, feel free to ask me any clarifying questions first. And what it did is it didn't help me build a presentation. It actually listed 10 questions that it wanted me to answer before it even got started. So it really kind of wanted to know like what I wanted before I started. So it gave me the right thing. And I find this like really helpful because if you just ask it the first part without the feel free, it may give you a presentation or maybe like way off from what you want. And because it doesn't know exactly what you want, doesn't know your audience. It doesn't know like what kind of tone you want. It doesn't know how long you want it. So you could specify all those things, but you have to think of them. I like this technique because you don't have to actually think of anything. You can use it for some ideas and maybe add one or two, but it gets you started. Next one. Yeah.
You know that Michael Cohen, the lawyer, that were involved in everything, made a brief for the court using AI, and AI made up cases to support his brief. And of course, the judge saw that. How did that happen, and how would you prevent that from?
Yeah, I mean, that's called a hallucination. I'm going to talk a little bit on the third section about hallucinations, if you just wait a little bit, but that's something you got to watch out. And the key thing is, like, don't use the tool for something you know nothing about, like it's a tool to help you. It's not a tool to like do your job or do your work. It's you still need to have some expertise, and you have to have that kind of like sanity check and things like that. But there's a whole, I'll get to it more in there's a lot of growing interest in showing the kind of having the tools be transparent and show that kind of stuff. So I'll touch on it in a little bit after some of the prompt engineering example. So this next one's called prompt chaining, and all this is really just keep asking it questions. So if it gives you an answer, in this one I had this example. It was about some design. I gave it some information about our design, and I said, hey, can you tell me about the top challenges? And it listed like 5 things. And one of them was fingerprint sensor. So then the next thing I asked was, can you tell me a little bit more about the fingerprint sensor? And it told me some things about the problems with the fingerprint sensor. And one of them was this dust ingress. So then I would just ask it again, okay, can you tell me a little bit more about the dust ingress? Go ahead. Absolutely.
Basically looking all over the internet for relevant snippets that this guy wrote this article, this guy wrote this.
Correct. Correct. And it's not looking when you use the tool. It's trained. So when they release like GPT-4 or GPT-4o or any of these versions, they have to train it first, and it takes months, and it takes like thousands and thousands of these expensive video cards and like tons of energy. Now I'll touch on that a little later. They train it basically on the internet. So they basically download the entire internet, every book published, every article written, news feeds and stuff. And I think they're up into the trillions of parameters. and they train the model on that, and then they make it available for us to use. What's that? Oh, paywalls. Yeah.
All that as the husbandry of the people of the key of the information. ARRL is all their information, waiting people will populate, create, artificial intelligence don't see it.
Correct. And I actually took it out of presentation, but I'll mention it here. There's something called RAG, which is retrieve, augment, generate. And we use that a lot at work. So what that is, so say you want to use the large language tool like ChatGPT, but you want it to be also trained on some things that are not public. Like maybe we have a bunch of product specifications or something like that. So we'll put them in a folder somewhere, and then we'll use a tool called a technique called RAG. We'll say, okay, remember everything that you've already been trained on in the internet, which we buy from OpenAI or Google, and now relearn all these stacks of documents, which is, private to us, and now open up like a ChatGPT type window where we can ask questions about those documents or anything that it learned on the internet or any combination of the two. So that's how like we, get around the paywall type thing is we actually use it internally. We have our own tools to do that. Now, many companies are doing the same thing.
Then it's not gonna, it's bought.
Correct.
Prompting, you ask, can you tell me about the top challenges? How does it know that you're talking about the challenges with fingerprint sensors as opposed to the challenges as a Spanish food?
Yeah. Oh, so there was some more before this. I didn't show that. So in this example, what I actually had done was, so I run a team of engineers. They had run something called a concept review we do before any major product decisions, like spending a lot of money to make mechanical parts and boards and stuff like that. So we do this big like event called the concept review, where we get together all the functions, the electrical engineers and the software engineers and mechanical engineers and everybody, and they spend like a whole day, going through everything to make sure things look good. And we recorded it on Teams. And I took all their slides, so hundreds of slides of data that they presented on the project. And I took their full recording of the day's event and used RAG to train it on that. And I said, okay, here's all the materials from our design review. And then I asked the tool, can you tell me about the top challenges of this design? And it went through all the recorded verbal text that we had done for the day and all the presentation materials. And it made a decision of like the most riskiest things that we had talked about.
Design competition. Certain questions could apply to you.
True. In this one, I was doing for a design thing, but really what I was trying to show here is the idea of like prompt chaining. Basically, you get an answer. You can ask like a kind of a broader question and then narrow it down and narrow it down and narrow it down, almost like a kid that keeps saying, well, why? You give them the answer. Well, why? What?
And then you have to separate tabs.
Okay, so your tabs would say
Yes,
contact.
your tabs. It was, remember the conversation they were supposed to have? So there's like different tabs.
Yeah, they call that a context window. That's the name for it. It's called a context window is like one tab of a conversation. And there's something called context window length. And when it first came out, like GPT 3.5, it wasn't that big. So if you were pasting in big questions or big documents, it would actually forget the stuff in the beginning because maybe it only had 3,500 words or something like that. But now all the tools, the context windows got much bigger. So it's remembering more of the history. But still, if you get like really long, if you're using the same tab, I'll say, or a context window for a month and you're putting like tons and tons of stuff in there, it will forget the early stuff. And also if you are paying for it, or somebody's paying for it, the more you have, the bigger you have that context window, the more cost is going up. Let's go next one. Or any. So next one is another, it's just a technique. I like to use it a lot. And really it's a way to use confirmation words to pause the tool before doing what you want it to do. So maybe I'll give it some instructions, like I'll put a prompt, and at the end I'll put, do you understand? And what that does is it causes the tool to stop and kind of regurgitate back to me that it precisely knows exactly what I want it to do before actually doing it. Because I found if you just ask it, sometimes maybe it didn't understand you and now it's off on a tangent. So this is a way to figure it out before it goes off on a tangent. Or you might use a word only after I have. So like one example I use often is if I have a kind of lengthy prompt where I'm asking it to a bunch of I want to show it by example. I'll say only after I have, confirmed that you understand the instructions, go do the actual thing. And then another one is confirm you understand the request, and then I will proceed with supplying like the last piece of information. So it's just a technique to get the tool to pause and make sure you're steering it in the right direction before you invest a lot of time down some wrong path and have to start over again. So there's another technique. It's called one or few shot learning. And it kind of relates to the question you had before about like it's trained on the internet, right? And they have something called a cutoff date. So I don't know the cutoff dates, but they're usually about 6 months before the tool is released. So like say Google or OpenAI is going to release a new version of ChatGPT. Say they release it in November. The cutoff date might be April because they need time to, the cutoff date is when they stopped like downloading the internet. So they downloaded the internet as of April. They spent a few months training it, refining it, and then you give it to the public. So that's something called a cutoff date. And you could use RAG like I was talking about before, but you either have to pay for a premium version of ChatGPT, or pay for a premium version of Google Gemini, which is around $20 a month, to get it to read your pile of documents that may not be on the internet. Or you can do this thing called RAG. If it's not information, but you want to teach it something, almost like teaching a kid or someone. So the first thing is called zero shot, which is basically when you just ask the tool a question, it gives you an answer. That means you're not training it at all. You're just using whatever it was trained on. But when you get into one shot, two shot, many shots, you can actually train the tool as you're using it. And the next slide will give an example. So I just put two here, a simple example, but the tools have gotten a little better in the last couple months, but early, like in March timeframe, all the tools got tripped up with this. So a zero shot example is, so say you have, if ABBC4 changes to ABBD3, what does PQQR7? And you can see all I did was change a letter and increment a number, right? And, a fifth grader could probably figure this out, right? Any human. But most of the tools got it wrong every time. And you can now use this one-shot technique or two-shot techniques. You can give it an example. So, you can answer the question, but say, here are two examples, and you're giving it DEEF. 4 goes to DEEG3, and maybe give it a second example, and then ask the question, and it will get it right like every time. And that's reason because you just taught it at runtime. It didn't learn this in its training from the internet. It learned it from you right now. That's a very simple example, but it kind of, the point I was trying to really share is that you can teach the tool as you're using it with just a few examples. And, one that I like to do here is, I had done this for a report that I had to do. So I had some input from my team, various things, and I had to get it into something that I had to give to my boss. And instead of specifying like exactly how to format it and how to take it and what things, were worthy of VP level communications and which things were, things they don't need to know about, I could have done that with a bunch of prompts. Instead, what I did is I took one I did like a month ago. I said, okay, basically last month I had done this with these raw inputs and created this finished product. Learn from that, and now do it again on some new stuff. So basically, that's kind of what this is. I said, here is an input and example output. I used a technique to pause it, confirm you understand. It came back and confirmed it understood. I gave it an input. I gave it an output. And then this thing at the bottom is where it said, I understand the request. So it learned based on my input and output, like what I was looking to do without me telling it. And then I was able to give it new information and it can repeat that like old job that I had to do. That makes sense? Okay. So it's just a technique. It's called one shot, few shot. This other one is pretty popular. It's called Chain of Thought. And before I get into this one, the OpenAI, the one they released last month, which is called 1.10 or 1.0, they included this automatically. So the need for having to do this is maybe going down a little bit with the new tool, but definitely the older ones, you have to do this with. And this is a good example of it. Is, you know, if you do, I was doing this in March timeframe. But I was born on, you know, you put your month, day, and year, what day of the week I was born. And I found actually half the time it gave me the wrong answer. And if you ask the same question and basically say, show all your work, like as if you were in school, it'll show all the work. And I found like every time it gave the correct answer. And that's called chain of thought. Is basically you're telling the tool you want to see how it thinks, or see how it came to that answer. And there's like lots of studies and everything that show just by asking it to show you how it got to the answer will give you a better answer than if you just ask it plain out. You don't know. But now it looks like the tools just in the last month are starting to build this in automatically, where even if you don't ask it to show you how it got to the answer, they're showing it to you anyway. And I'll get more of why they're doing that, because they're getting a lot of heat from, I guess, maybe the thing that you were mentioning before, where you ask the tool to do something or for some information, you have no idea how it came to that answer. And then that leaves you with some lack of confidence. Is it correct or not? So now the tool is kind of starting to do that automatically.
You guys mentioned previously that I asked the question, it gave me an incorrect answer. I corrected, it thanked me for the correction. Subsequently, I asked the same question, gave me the incorrect answer. And I said, are you able to make changes? And it said, no, I cannot make changes to the information that I've got.
Yeah, it's probably referring to it can't change what it was trained on. I'm guessing. You probably could have done a 1-shot or 2-shot learning saying, you got this wrong, but this is the correct answer. And then asked it maybe a little variation, and maybe it would have got it right the second time. It could, you know, say use this as an example. But if you opened another tab or another session, like that memory is gone. It's not going to remember it. Like when you go in ChatGPT, it saves all your sessions on the side. So each one's independent. They know each one doesn't have memory of the other one.
Schrodinger's paradox, where the situation under observation or observing it changes the outcome.
Yeah, I'm not familiar with that, but the studies show like when you ask it to show that work, it's a much, much higher probability of a right answer. Why that happens, I have no idea.
Okay, when I was preparing the log for this month, I've been reading works by a gentleman named Walter Isaacson. I bet at least some of you have heard of him. He's a well-known biographer. He wrote biographies of Steve Jobs from Apple, Benjamin Franklin, Albert Einstein, and quite a few others. And in the of the book that I was reading, it had, and it said he was a ham radio operator. So I asked ChatGPT, well, what's this guy's call sign? And it came up with a call sign. So I looked that call sign up on QRZ, and it had absolutely nothing to do with Walter Isaacson. It was a complete fabrication. So I came back and said, how do you know that that's his call sign? And it apologized because it said it lied to me.
Good.
Could be a pseudonym.
So So yeah, that's what chain of thought is about. It's just a technique to use to get better answers. But you always run the risk of getting a wrong answer. Next one. Next slide. So this last one is not really a technique, but I just wanted to share it to make you aware is, like I mentioned before with GPT-4, not 4.0, GPT, the newest one, 01, they're adding that chain of thought automatically. And what they're doing is they're doing that as a meta prompt. And a lot of tools use this. And basically all it is it's before you even type your first prompt in there, there are some rules and guidance on these types of things and the types of things I showed before already in the tool. So say there was an AI tool for Home Depot, right? Giving customers information, you know, in their paint department or something like that. They may set up things in the beginning that, hey, you are a paint professional. You know all the paints of Benjamin Moore and the Behr brand and all that. And it might also have things called guardrails, like telling it what not to answer about, like, because maybe they don't want an answer that now Home Depot gets sued or, you know, shows up on Facebook or something like that. You know, it could make, you know, derogatory statements or something like that. So that's guardrails. So I just wanted to share this. This is not something an end user does, but all these tool makers, they have these things called meta prompts, and they're putting these in to kind of control that window that you're using to not kind of go off the rails. Okay, so that was it on prompt engineering. Like I said, it was just a kind of handful of tricks and techniques that I use to find kind of get to that next level. And here I'm really just going to share, this is more like informational, but just share some of the challenges like we've been talking about a little bit and some future things that are going on that I see in the news and things like that. So, you know, stop me if you have questions, but this is more just kind of informational or like definition. So the first one that's really popular is hallucinations. And these tools, they call it a hallucination when it just makes stuff up, right? And part of the problem with hallucinations and why they get bad press is part of it is because of a bad prompt. So if you just asked it something like, hey, write me a speech for my my best friend, I'm the best man in the wedding, right? It's just going to literally make things up that never happened. I mean, you can use that speech, but like nothing will be real because it doesn't know anything. But if you structured a prompt and you gave it some history and you gave it some information and things like that, then you're going to cut down on those hallucinations. Like, okay, maybe it might make up one or two things, but for the most part, it'll use the context you use. And like, that's how I use it at work all the time is I write a weekly blog to my team. So what I do is I usually kind of have some rough content and I say, use this content to write a blog. And I use those prompts to set the tone. You know, I want it to be inspirational. I want to, you know, drive readership of my blog and all this kind of stuff. So it knows that context. And then it takes my raw material and makes it into something that's, you know, exciting to read and that the team finds informative and enjoyable. So that's what a hallucination is. There's a lot going around about security and data privacy. Obviously, the AI tools have to worry about this as well. You know, when they do all this training data, they have to make sure that it's called data anonymization. So they have to make sure that there's not like personal things in there. Like the last thing Google, OpenAI wants is to train things and it has people's personal information or things that can link them to a person. They have to design against attacks. So all these tools, as soon as they get released, all the bad guys are in there trying to attack the things and trying to kind of figure out their secret algorithms and figure out weaknesses and stuff. Like the day after the day of their release, they're attacking these things. So before any of these tools are made, they do have to worry about like security and data privacy. Next one. Copyright and data theft is a big deal. Copyright infringement. I'm not a legal matter, but my understanding is that works that are purely generative AI, like generated by the tool, cannot be copyrighted, or the person that's using it can copyright it, but you don't know if that was trained on things that might be infringing on patents or like those other things. So you always have to worry about what you're using, especially in code development. This is a big like controversial topic in software code development, like who owns it if the AI is writing it and where did it learn it from? Next thing, next slide. So shadow AI is, what that really means is like, I guess the best way to explain it is this. In 2023, when ChatGPT was getting really, really popular, people were using it, right? Whether the company says you're allowed to or not, they're going to use it anyway. And I think it was Samsung. Was in the news that secret design stuff's got leaked out to the tools to other people. So what did like most companies do? They just put up their firewalls. They're like, no employees are allowed to use ChatGPT. We're going to shut it off. And like our company, actually, what we did is we did shut it off. And then we said, we're going to build our own tools and, run on our own servers and stuff like that. So it's all safe. But really what shadow AI is your employees or people are going to use it anyway. So that's kind of what the term shadow AI is, that it's better to like embrace it and find ways that they can use it safely than to just ignore the problem or try to block the problem. Because I would bet when Samsung did that, their employees went home on their home computer and used the AI tools anyway. So bias is also something they have to watch out for. And these examples, actually, I had AI write the examples, but depending on what you, actually a lot of this material here, AI wrote a lot of the material for this presentation. I guided it, but what bias is depending on how you train the data, like you may inadvertently create a bias like if you trained, say it was facial recognition and you trained it on mostly because the data you had was, mostly white males or something like that, then it may mistakenly, bias towards one group or the other. So it's like important for them when they're training the data to make sure there's no inherent bias, because even if you're not intending to have any bias, if you just kind of use the output blindly, you might get inferred bias by how the data was trained and not know it. Next one. So this is just a technique. I just wanted to share the definition in case you heard the word. It's called overfitting. And really, this is what happens if almost you overtrain the data. So you can overtrain the data so much that it can maybe reject things that are valid. I thought this little graph did a good visual interpretation. Like if you were kind of training this for some kind of model, you might make like a nice shaped curve where the X is on the left side and the O is on the right side. And once in a while you get one wrong or something like that. But like I'll say a nice fit. If you train it so much that it makes some kind of crazy shape and then the input is not coming in that shape, things won't fit. So I just wanted to really kind of share the term of overfitting, and it's something that these not users of AI, but the people who are the makers of AI, they always have to worry about and have that right balance of training it enough, but not training it too much. And this one I thought was very interesting. There's like this was from a presentation I did in August, but to train all this data, it takes it's not green by any means. It requires expensive video cards. That's the most popular one. Is called the NVIDIA H100. It's about $30,000 a card. And, they'll use, in this example, what was it? So this Llama 3.1, 4.05B, that means 405 billion input parameters. To train it took $16,000 of those $30,000 cards. So that's $500 million. And they got to run these things for like weeks. And I saw some statistics. Now, GPT-3 is pretty old. You got to remember, like that's pre-2023, because then ChatGPT was popular when GPT 3.5 came out, then 4, then 4.0, then now they're in GPT-1. So they're not even publishing the numbers anymore because maybe they don't want no one to know. But when GPT-3 was around, which is 175 billion parameters, it was 552 tons of CO2, which is equivalent of 120 American cars. And I just saw in the news, usually takes like a month or something like that. Yeah. And I just saw in the news, I don't know if it was OpenAI or another one, they're actually buying a nuclear power plant. So that just, you can kind of search it. It was maybe like 2-3 weeks ago. 3 Mile Island, that's it. Yeah. and it's being bought by, reactivated by Microsoft. Yep. There you go. And the reason is so they can power these things to run, which, yeah. So I thought that was pretty interesting that, like this is definitely a, public concern about this. And like, I saw a newer thing that by 2030, I think it was like almost 20% of the electricity use would be just on AI, total global use or something like that. Pretty interesting. Next slide. So multimodal, you may have heard of it. And what all that really means is in the beginning, when ChatGPT came out, it was just text. Multimodal means using text and video and images and sound as inputs, and also having text and video and sound and images as outputs. So an example might be you give it text to say, create me a video of this, and the output is the video, not the text, or the other way around. You had a question?
I suppose it, because GPUs use a lot of linear algebra to manipulate images, so they decided that the linear algebra for AI would run well on those same boards.
Correct. And I kind of blasted through it in those early slides, but when I was showing those neural networks, because all this stuff is run on neural networks, the math to do all those, the 0.5 that went up by 1 and down by 1, it's all matrix math. And matrix math is like perfect for GPUs. Like a CPU can do it, but you can code it in C, but it's going to take a long time. It's going to be in loops, like it'll be in a loop, right? So it'll be very sequential and take a long time. Whereas a GPU, it's made for matrix math, and it could do the whole thing at one shot. So that's why these video cards became super, super expensive. Like anyone that had a gaming PC before AI took off, it wasn't that much, but now they've all skyrocketed, and so has NVIDIA's stock. And exactly. That was right. That was the trend before it. Everybody was mining Bitcoin. Go ahead. Oh, there is something called backconfiguration. Yeah, that's getting like PhD level into that stuff. Like I said, I actually don't have any training in AI. This is just stuff I've learned this year, really just studying it and applying it and sharing it. Any other questions? Go ahead. Analyze what? Yes. Correct. Yeah, that was the example I was showing before. Not really. It was basically pulling from the discussion we had, because I had put that recorded transcript in. But where I really found it useful was after I wasn't in the meeting, right? It was my team. So I actually used that. I asked it questions about the meeting, like, how'd my team do? Did my team talk about past lessons learned? Did they, and I was able to assess the behavior of the team a little bit. But what I thought was really interesting was on those risks, that it didn't give us a surprising thing. We actually use it to brainstorm. And I use that a lot at work for other things. Like, so say maybe we were stumped on something and we have an idea of what to do. I'll put the problem and I'll say, give me 10 possible things we can do about this. And maybe we knew of like 6 of them, but if there's even 1 or 2 that we hadn't thought of, and it turns out to be like a good idea, it's worth it to put it in. So sometimes I'll ask it an open thing and say, hey, give me some ideas. All right. So this other one, I'm kind of excited about AI agents. So all the stuff before was about using generative AI, like kind of Q&A. And really the whole thing about an agent is empowerment. So basically when you use the tool, you're commanding it, you're in control. The idea of an agent is not only do you talk to the tool, but you're giving it the power to go do it when you're not there. So in other words, maybe you want to have it start answering your emails for you, right? Of a certain nature, like say, this is coming soon. Like this is going to be launched. Like, Microsoft's going to roll it out. All these tools are going to roll out. Like it's going to be here. And it already is there. Like I had, last year I was at a vacation rental by owner, up in Northern Vermont. And on the Verbo app, they have like customer service. And I was going back and forth with the app and I thought it was a real person. And then it occurred to me, this is not a real person anymore. This is an agent, And so I started asking it questions to trick it up and stuff. And it did. It was an agent running. But the idea is that like agents are coming soon to maybe where they can, monitor how you're using, or you can train it how you respond to certain things. And then it could do it on your behalf when you're not there. That's really the concept of an agent. I would say probably, yeah, spam, like all these automated bots and stuff, they're all agents. And, what makes me excited is like, I think we're going to get to use them soon. And maybe I can use them in the workplace, make my life a little simpler where I can focus on more meaningful things.
Do you need to be aware of Project AI? Is constructing a prompt for ChatGPT any different than constructing one for Copilot or Gemini or Meta AI or whatever?
I would say yes. I haven't used them all, but I would say there's one built into GitHub that's like really good at doing code. So obviously, if you want to help write Python code, you would use that one. You can do the Python code in ChatGPT, but it may not be as good. And then there's ones made for like there's thousands out there. There's ones made for videos, and there's ones for images and things like that. So yeah, it's really picking the right tool for the right thing. My experience has only been with the text-based tools, mostly because they were free, but then trying out the paid versions as well.
Question?
Go ahead.
Yes. So if you sent me an email and I decide not to open it up and delete it, will AI know that and notify you and or not notify you or give you the capability of being able to research the notification that I did not open it?
Yeah, I'm not sure about the notification part. That might be something you enable, like my email. Like if you send me an email, I don't think I notify you that I opened it or not unless I open that access. But I guess the idea as the agent is you would give it some rules and some training to take the actions on your behalf. Did I answer? I'm not sure I fully understood the question. I guess so. Okay.
He dropped off. I don't know what happened to him. He was on the phone.
Okay, no problem. We'll keep going, and if he comes back. Yeah. The next slide. I'm getting towards the end. There's just a couple slides, I think. Oh, can we go next?
Next slide.
Okay, so I touched on this one before, but this is like a new trend, and actually it's a good thing for us, is this concept of explainable AI or XAI. So the tools are basically, I think in general, the public is getting a little concerned, like what are these tools, what's happening behind the scenes, and what explainable AI is it's an initiative for all the tool makers to make things kind of show you how it got there. And I think is in general a good trend that this keeps up, that the tool makers will make things show the work and give people more confidence in the tools and what they get out of them. So I really just wanted to share. I have a lot of words on this slide. You can look at them. I'll leave with everybody. But that was really what this was about. If you hear it in the news or something, explainable AI, that's what it is a trend to be more transparent. Yeah. Yeah. Or even show kind of how the tool is functioning. And then this, I think this is my last slide, is there's also a lot about edge AI, and we do a lot of this at my work. And what that is we want to know, like, edge AI, most AI is done in the cloud. So end devices, whether it's your text input on your computer or your video from your phone or a security camera, they got to send that video up to the cloud. It gets processed, and it's like, okay, that's an intruder. The idea of edge AI is, well, can you do the simpler tasks, or can you put like a little GPU in the camera module where now it doesn't have to use all that high data pipe up to the cloud, and you don't have to pay for the cloud cost? Can you do a more refined and smaller model on the camera? And where it's important is one, for cloud costs, but it's also important for things that you need. You don't want to rely on a data connection, or you need a fast response, like video games. You wouldn't want, like if you had a VR headset, you wouldn't want it to have to send the data to somewhere and send it back. It might be too slow that it'll feel laggy. Or like a car, like a Tesla driving down the road, it doesn't want to have to send all the images that it's getting up into the cloud and back. So they call that doing it on the edge. Is basically the trade-off is, well, now you have to put expensive parts, in those cameras, and they use a lot of power, and they cost a lot of money and things like that, or they may not fit. So there's a whole trend of like models at one time were getting bigger and bigger and bigger. Now the trend is actually, are there smaller models that we can do for a specific task that we can do on device or on your phone? Like I think the Pixel 9 is supposed to be AI powered or something like that. And the idea is, like a lot of those tools, like maybe the Gemini tool or language translation, you have to have a data connection. But if the phone is capable enough, you can do it when you have no cell service. So that's kind of where they're going with that. And that was really it. I hope you found it interesting. So thank you, everybody. Nice to meet you. I've heard your voice many times, but never seen you in person.
Oh, appreciate it. And it was a great talk. We're very appreciative of that. Thank you very much.